Hello, good morning everyone. It's me again, Sir Levy. So in this video, I'm going to show you how to perform division of polynomials using the synthetic division method. We are in the same MELC again, our most essential learning competency, performing division of polynomials, but this time it's on doing synthetic division method. We have the same objective. So I'm gonna go ahead and then close this camera so that I can show you my notes. There is a shorter way when a polynomial is to be divided by a binomial in the form x minus r. So this method is called the synthetic division method. So what is all about this synthetic division method, and why not use this method earlier in the discussion? Okay, so first thing is that synthetic division method is only applicable when your divisor is in this form, x minus r, a binomial in the form x minus r. So if your divisor is not in that form x minus r, then you cannot do this method in dividing polynomials. So you need to stick with the long division method. Okay, so this is just a short way of, or a trick, or a hack in doing division of polynomials when your divisor is a binomial in the form x minus r. So what do we mean by that? So here is an example of the synthetic division method. Use the synthetic division to divide our p of x is 3x cubed plus 4x squared plus 8 by the divisor x minus 2. Sorry, this is x plus 2. Okay, so you notice that our divisor is a binomial. That means you have two terms, and the term is in the form x minus r. So that means the highest degree is x raised to 1. So our variable involved is just x, and then you have the constant. Our constant negative r is positive 2. So later we'll deal with that. Okay, so here is our first step. Okay, step 1, arrange the coefficients of p of x in descending powers of x, placing zeros for the missing terms and writing it in the first row. Okay, so first is you are going to arrange this given polynomial expression in descending order of powers. Obviously, this is already in standard form. So the descending order of powers is, first is you have 3x raised to 3, next is 4x squared, and then we don't have a term for x raised to 1, so it's missing, and then you have the constant term. So we are going to arrange them in descending order of powers. Again, we are looking into the powers, not the arrangement of the coefficients. So if we are going to arrange them in descending order of powers, the first one will be 3, next is 4, and 0. So why do we have 0? Remember that we don't have a term for x raised to 1. That's why we put 0 there. So remember, in long division, if a term is missing, we leave a space or we write 0. That's why we have 0 here. And then for the constant term, 8. So that is our first step. So take note, you need to place 0 for the missing terms in among the coefficients. Alright, so our second step is place the value of r in the upper left corner. In this example, our x minus r is x plus 2. So you notice that if it's minus r, it's positive 2. Therefore, there is an inverse relationship of the operation. Okay? So when you have x plus 2, that actually means that we have x minus negative 2. Remember, negative times negative is positive. That's why we have here x plus 2. Therefore, our r is negative 2. Basically, yung gagawin natin is just kung ano yung value ng kanyang constant term, we just get the inverse operation of that. So if it's positive 2, then our r is negative 2. And that is because of the negative sign of r. Okay? So for our second step, we are going to place the value of r here in the opposite corner. So we have negative 2, and then the coefficients of the given polynomial expression, we have 3, 4, 0, and 8. The third step is the first entry in the third row is the leading coefficient of p of x. We are getting the product of 3 and r, which is negative 2. So basically, the first step is our leading coefficient 3 here. We just bring it down. Okay. Next step is 3 times negative 2. And the result of 3 times negative 2, you're going to put it here. You have negative 6. Next step, we are going to combine these two terms in the same column. So you have 4 plus negative 6. Take note of the operation here. When we combine, we add. Okay? So we are adding. So 4 plus negative 6, we have negative 2. Okay? For the fourth step, you are going to repeat the procedure described in step 3. So you have negative 2 as a result. And that negative 2, you're going to multiply it to negative 2. So you have negative 2 times negative 2. The result is positive 4. And then you combine 0 and 4. So that means you add 0 and 4. The result is 4. Okay? So after this one, you need to multiply again 4 to negative 2. And the result is negative 2. And then combine. Okay? So the last number here is 0. Okay? So step 5. Okay, so write the quotient q of x and then note that the degree of q of x is 1 less than the degree of p of x. So by the way, you also need to note that in this example, the last entry for the third row, so take note, this is our third row, okay? Third row. The last entry is our remainder. That means in this example, we have 0 remainder. So the resulting coefficients are 3, negative 2, and 4. So you need to take note of these coefficients because we are going to express now our final answer, the quotient of the problem. I'm using these coefficients with the variable 1 less than the power of the given. Okay, so the given problem is x raised to 3. So yung gagamitin natin is, it should be 1 degree less than x raised to 3. So it's x raised to 2. Okay? And so on and so forth. Pababa na yung order, descending order na yung kanyang mga variable. So that's why the coefficients, since we used 3, negative 2, and positive 4, so yung 3, gagamitin natin yan dito sa first term. And then the variable of the first term should be 1 degree less than the highest of the given. So that's why we have x raised to 3, x raised to 2, sorry. So you have 3x raised to 2 minus, so you have minus 2x. Yung kasunod ng x raised to 2 is x plus 4. So you have x raised to 0. So, or the constant term. We don't have a remainder, so that means our answer could be written in that form. So you can write your final answer as our quotient is 3x squared minus 2x plus 4. And that's how you do it using the synthetic division method. So this is just an alternative way of solving division of polynomials. Instead of using long division, you have the synthetic division. And take note, it is only applicable if our divisor is in the form x minus r. Okay, so we have another example. Use synthetic division to find the quotient of x raised to 4 plus 8x squared minus 5x cubed minus 2 plus 15x, and that is to be divided by x minus 3. So by inspection, our divisor is a binomial in the form, so this could be written in the form x minus r. Okay, but first thing that we need to do with our given polynomial expression is to arrange them in standard form. So the standard form of this given is, we have x raised to 4, x is minus 5x cubed plus 8x squared plus 15x minus 2. Notice that there are no missing terms, so that's very nice. Okay, so we can proceed now to our synthetic division method. Synthetic division. Okay, so in synthetic division, we only need to write our coefficients of the terms. Okay, so I'm underlining the coefficients. So you have 1, -5, 8, 15, and -2. And then since our divisor is x minus 3, and we follow the form x minus r, therefore, our r here is 3. Okay, our r is 3. So we are going to write 3 in the opposite corner. Okay, so we now proceed to the operation using synthetic division. So first, we bring down our leading coefficient. Okay, then 1 times 3, that is positive 3. And then we combine these two numbers. In the column, you have -5 plus 3. The result is -2. Next is multiply -2 to 3. The result is -6. Then combine again 8 and -6. The result is positive 2. And then multiply again 2 times our r, which is 3, and we have 6. Then combine 15 and 6, you have 21, positive 21. Repeat the same procedure, 21 times 3, you have 63. And then combine -2 and positive 63. The result is -61. And this -61 is our last entry in the third row, and that means it is our remainder. This is our remainder. Okay. Now, take note that our given expression is in degree 4. Okay, so it's the highest variable, the highest power of the variable x is 4. So we're going to express our final answer. So remember that it should be a 1 degree less than the degree of the given. So take note, you divided x raised to 4 by x. So supposedly the result should be x raised to 3, and x raised to 3 is 1 degree less than x raised to 4. So we are going to consider these coefficients in expressing our final answer. So the result is, so you have 1, that means you have 1x raised to 3. Then you have negative 2x raised to 2. Then you have positive 2x raised to 1. We're simply write x plus 21x raised to 0, or that is our constant term. What are we going to do with this negative 61? So that is our remainder. And remember that with our remainder, we write it as the numerator part of our fraction. So it's negative 61 over the original divisor, which is x minus 2. We just need to copy that x minus 3, and that is our final answer. So that's how you do division of polynomials using synthetic method. And then we're going to proceed with our next example. Use synthetic division to find the quotient of 6x raised to 5 minus x raised to 4 minus 32x cubed minus 20x squared plus 5x plus 8. And that is to be divided by 2x minus 3. Alright. One thing to note that our divisor is, yes, a binomial, first degree binomial, because you have x raised to 1, but it is not yet in the form x minus r. So remember, it should be in this form, x minus r. Okay, so it is not that much of a big deal, because we can convert this 2x minus 3 to this form. Okay, x minus r. So what are we going to do? So you have 2x minus 3. So instead of using 2x minus 3 in our synthetic division method, what we're going to do first is to factor out or divide both terms by 2. Okay, so that we can eliminate this coefficient of x in the process. Okay, so we're going to factor that out and divide both sides by 2. So 2 divided by 2 is 1, so 1x. Okay, and then you have negative 3. You factor 2 plus negative 3. Of course, the result is negative 3 over 2. Okay, now this thing here inside the grouping symbol x minus 3 over 2, it is in the form x minus r. Okay, so we can utilize this in the meantime, this x minus 3 over 2 first in doing our synthetic division. So what we actually do is we just disregard the coefficient of x. So that's why you factor it out. We factored it out. Okay, so we are going to utilize this part here. Hindi tayo mahirapan in doing our synthetic division, because take note, it should be in this one, x minus r. Walang coefficient. So, i-factor out muna natin yung 2. And if that is the case, if we are going to use x minus 3 over 2, the value of r in this problem is 3 over. So, take note, negative 3 over 2, you have negative 3 over 2, you have negative r. That means since the value of r is equal to positive 3 over 2. So, sabi ko pa nga, you just inverse the operation of r because you have negative r here, so you inverse negative 3 over 2. Okay, so we can now proceed to our synthetic division, since we can obviously see that the given polynomial is instead. So we are just going to make use of the coefficients of the given polynomial expression, and we have um, 6, you have negative 1, 32, sorry, no, I should write this. We have 32, it's negative 32, you have negative 20, positive 5, and positive 8. Okay, we're going to put them inside this symbol, our division symbol for the synthetic method, and then we are going to put our r in the opposite corner. Our r in this case is 3 over 2. Okay, first step, bring down the leading coefficient. You have 6. Next step, 6 times 3 over 2. Remember your lessons in fractions when you multiply a whole number by a fraction. So what you need to do is multiply the whole number to the numerator and then divide it by its denominator. Okay, so in this case we have 6 times 3, and you know that's 18, and 18 divided by 2 is 9. And then next step is to combine these two numbers in the column. You have negative 1 plus 9, and you have positive 8. You do the same procedure with 8. 8 times 3, that is 24. 24 divided by 2, you have 12. So you're going to write 12 here. And then combine these two numbers in the column. You have negative 32 plus 12. And the result is negative 20. Next step, multiply it again to 3 over 2. So you have negative 20 times 3, that's negative 60. Divided by 2, you have negative 30. You have negative 30, and the next step is combine these two numbers here. You have negative 50. Next is multiply negative 50 to our r. So you have negative 50 times 3. That is negative 150. Okay, and then negative 150 divided by 2 is negative 75. Okay, and then combine 5 and negative 75, and you will get a result of negative 70. And then do the same step, multiply negative 70 to 3 over 2. Negative 70 times 3, you have negative 21, negative 210. Negative 210 divided by 2. What's the result? Negative 105, I guess. Oh yes, negative 105. Okay, and then you're going to write negative 105 at the last column, and then combine the two numbers in the column 8 and negative 105. The result is negative 97. So So let us put a mark on this last entry in the row. You have negative 97 because this is our remainder. Okay, so the coefficients in the third row is 6, 8, negative 20, negative 5, and negative 70, and our remainder is negative 87. So what are we going to do with those coefficients? Of course, we're first going to consider the degree of the givens, x raised to 5. So it should be 1 degree less than the given since we divided by x. So it should be, the quotient should be 6x raised to 4 plus 8x raised to 3 minus 20x squared minus 50x minus 70, and then we are now on the remainder. It's plus negative 97 over, so take note our divisor is x minus 3 over 2. Okay, but this is not the final answer yet because you notice that the denominator of the fraction part is x minus 3 over 2, and that is not our original divisor. Our original divisor is 2x minus 3. So we need to do something first with this answer to arrive at our final answer. Okay, so what are we going to add? So we need to add, we need to multiply our denominator with 2 so that this will be equivalent to 2x minus 3. And since we added 2 in the denominator, you also need to add 2 to all the terms in our answer. So you have over 2, or a denominator of 2 in each of the terms to make our expression balanced. Okay, so what is now our final answer? So our final answer is our p of x over p of x is this one. 6 divided by 2, you have 3x raised to 4 plus you have 8 divided by 2, you have 4x raised to 3 minus you have 20 divided by 2, it will be 10x raised to 2 minus 25 x minus 35 plus negative 97, and in this case, because we already multiplied 2 to our denominator, so we will now go back to the original divisor, which is 2x minus 3. And this is our final answer. Okay, so that's it, everyone. I just showed you how to do division of polynomials using the synthetic division method. Please take note that the synthetic division method is only applicable when our divisor is a binomial in this form, x minus r. So if the divisor is not in the form x minus r, so and you cannot convert the divisor in this form x minus r, then you need to use the long division method in doing your or performing your division. So that's it for today. See you in the next video.